Today we are going to see how to find the regression lines for x on y and y on x using the values of x and y star. So today we are going to see regression lines. Regression lines for the discrete data we have two regression lines. For discrete data we have two regression lines. The first one is regression line on line y on x. So it is denoted by y minus y bar is equal to r sigma y divided by sigma x into x minus x bar. Similarly, regression line x on y is defined as x minus x bar equal to r into sigma x divided by sigma y into x minus x bar. Sorry, y minus y bar. Here, here x bar denotes the average or mean sigma x by n. Y bar denotes the sigma y by n. Next, sigma x is equal to called standard deviation, which is equal to square root of sigma x square divided by n minus sigma x by n the whole square. Similarly, sigma y, the standard deviation for y is the square root of sigma y square divided by n minus sigma y by n the whole square. Next, how to find the value of r? Here the r is the correlation coefficient. R denotes the correlation coefficient, and R can be computed using the formula R is equal to covariance of COV denote the covariance of xy divided by standard deviation of x into standard deviation of y, and the formula to compute covariance of xy is equal to summation xy divided by n minus summation of x by n into summation of y by n. Here n denotes the number of data. N denotes the number of data. Note, we can able to find the regression lines without finding the correlation coefficient R, that is R into sigma y divided by sigma x is called as b of yx, and r into sigma x divided by sigma y is called as b of xy, and the b of xy and b of yx are called the regression coefficients are called the regression coefficients. And the formula to compute the regression coefficients are b of xy is equal to n into sigma xy minus sigma x into sigma y divided by n into sigma y square minus sigma y the whole square. Okay, this is the formula to compute the regression coefficient of b of xy. Similarly, the regression coefficient for byx is equal to the same thing n into sigma xy minus sigma x into sigma y, and the denominator will be for x, that is n into sigma x square minus sigma x the whole square. So directly we can use this formula to find the regression coefficient, and we can apply it in the formula to get the regression lines. Note, the regression coefficients using the regression coefficients we can able to compute the correlation coefficient that is b of xy into b of yx will be is equal to r into sigma x by sigma y into r into sigma y by sigma x, so which is nothing but your r square. So you will get r is equal to under root of b of xy into b of yx. So from this, uh, we can able to compute the correlation coefficient. Also, the sine of r is the sine of b of xy or b of yx, since b of xy and b of yx will always have the same sign. So we can use any one of the sign. So that is r is equal to plus square root of b of xy into b of yx if b of xy is positive or r is equal to minus square root of b of xy into b of yx if b of yx is negative or b of xy is also is negative. Next, secondly, we can able to compute the ratio of the standard deviation. Also, we can able to compute the ratio of the standard deviation that is b of xy divided by b of yx. This ratio will be r into sigma x divided by sigma y divided by r into sigma y divided by sigma x. Here r will be cancelled. You will get sigma x square divided by sigma y square. So this is nothing but the ratio of the variance. So on square root will give you the ratio of the standard deviations. So this will be your ratio of the variance. Ratio of their variance. Now I'll explain this concept by with an example as follows. Take down example problem. Compute the two regression lines for the following data. Here the data values are x, which is the color. So the x values will be 2, 3, sorry, 2, 4, 5, 6, 8, 11, and y values are 3, 7, 8, 10, 12, and 17. So now we are going to find the two regression lines for the following data. Okay. For that, we need the following values, that is n sigma x square, sigma y square, and sigma x square. So we'll compute all the values first. So which is the color? I can use this. So here n is equal to 6. Okay. Next we'll write the values x value, next y value, next x square value, next y square value, next x y. So these are the values are required. So the x values are 2, 4, 6, 8, 11. So x value is 2, 4, 6, 8, 11. So corresponding y values, the x values are 2, 4, 5 is the 5 here. 2, 4, 5, 6, 8. 2, 4, 5, 6, 8, 11. So 6 data 2, 4, 5, 6, 8, 11. The corresponding y values are 3, 7, 8, 10, 12, and 17. Next, we need to compute the following values. First, x square values. So the x square will be 2 square is 4, and 4 square is 16, and 5 square is 25, 6 square is 36, 8 square is 64, and 11 square is 121. Next, y square values are 3 square is 9, 7 square is 49, 8 square is 64, 10 square is 100, 12 square is 144, and 17 square is 289. Next, we need to compute the value of xy. So 2 threes are 6, 4 sevens are 28, 4 eights are 40, and then 6 tens are 60, 12 eights are 72, and then 11 into 7, which is 187. Sorry, 12 eights are 96. 12 eights are 96, and 11 into 7 will be 187. So now I need the sum values. The sum of x values will be 36, and the sum of y value will be 57, and the sum of x square value will be 266. Next, the sum of y square value is 655. Next, the sum of xy is 417. So using this data, we are going to find one by one. Okay. So first we will find your x bar and y bar. These are the values are required. So first x bar will be is equal to sigma x divided by n. Here n is 6, so 36 divided by 6, which is equal to 6. Right? So we got your x bar is 6. Next y bar, which is equal to sigma y divided by n, such is equal to 57 divided by 6, so which is equal to 9.5. Okay, next we need the regression coefficients. So first we'll find the regression coefficient Vyx. So the formula to compute Vyx is n into sigma xy minus sigma x into sigma y divided by, so Vyx, so you'll get n into sigma x square minus sigma x the whole square, right? So n is 6 into sigma xy is 417 minus sigma x is 36 into sigma y is 57 divided by n is 6 into sigma x square. So sigma x square is 266 minus sigma x the whole square. So 36 the whole square. So if you simplify this, so you'll get the value as 0.5. So you'll get the value. This is equal to 1.5. Clear? So we got this value as 1.5. Similarly, v of xy is equal to n into sigma xy minus sigma x into sigma y divided by n into sigma y square minus sigma y the whole square. So you will get the numerator will be 6 into 417 minus 36 into 57 divided by sigma y square is 655. So 6 into 655 minus 57 the whole square. So we get the value of byx, we got it as 1.5. Similarly, bxy value, so if I compute, so I'll get 0.6608. So using these two values, now we are going to compute the regression lines. So I'll write it. So I'll write all the values will be. So yeah, I'll write down the x bar value is 6, y bar is equal to 9.5. Is it right? Yeah, y bar is 9.5. B of yx is equal to 1.5 and B of xy is equal to 0.6608. Okay, so I'll write the regression lines one by one. First regression line y on x, the regression line y on x will be y minus y bar is equal to b of yx into x minus x bar, so which is equal to y minus, which implies y minus y bar 9.5, so which is equal to b of yx value will be 1.5 into x minus x bar, so your x bar is 6. Similarly, yeah, the final line will be y is equal to 1.5x minus 1.5 into 6 plus 9.5. So 1.5 is 3 by 2. So y is equal to 1.5x minus 3 by 2. Yeah, 1.5 or 3, 1.5 into 6 will be, will get 9, I think. Yes, 9. 6 5s are 30, 0, 3, 6 1s are 6 plus 3, 9. So 9.0 plus 9.5. So we got the line y is equal to 1.5x plus 0.5. And this is here regression line y on x. Similarly, regression line x on y. So regression line x on y will be x minus, just put up, so x minus x bar is equal to b of xy into y minus y bar. So this will implies x minus 6 is equal to, and b of xy is 0.6608. So 0.6608 into y minus y bar. Y bar is 9.5. So you will get the value will be x is equal to 0.6608y minus 0.6608 into 9.5 plus 6. So x is equal to 0.6608 y 0 minus 0.2775. Also, note that using this regression coefficient b of xy and b of yx, we can able to find the correlation coefficient that we will see. So b of xy is equal to 0.6608, which is positive. B of yx is equal to 1.5. Okay. B of yx is 1.5. Okay. So now we will find the regression coefficient. So regression coefficient, sorry, correlation coefficient. These are the regression coefficient. Correlation coefficient R of xy. Here both b of x and b of yx is positive. So plus times of square root of b of xy into b of yx. So you will get plus square root of 1.5 into 0.6608. So from this we got the answer is 0.9956. Since the correlation coefficient values lies between 0 to 1, so plus 0.9956. Next, sigma square x divided by sigma square y. This value will be is equal to b of xy divided by b of yx. So which is equal to b of xy value will be 1.5, right? Yeah. So 1 point, sorry, 0.6608. So 0.6608 divided by 1.5. Okay. The ratio of the ratio, the variance x and y is 0.6608 is to 1.5. So these are the extra information we can able to get it from the regression coefficients. Okay. Once again, I will explain the problems. So we'll go move on to the question side. Yeah, the question is compute the two regression lines for the following data. The data are x and y are given. Here the x and y are simple data 2, 4, 5, 6, 8, 11, and y will be 3, 7, 8, 10, 12, and 17. So the number of data will be 6, that is n is equal to 6. So first we need to compute sigma x, sigma y, sigma x square, sigma y square, and sigma x square. So the the values of sigma x will be 36, sigma y is 57, sigma x square is 266, and sigma y square is 655, and finally sigma xy is 417. So next we have to compute the value of x bar, y bar. The x bar value will be sigma x by n, which is 6. Y bar value is sigma y by n, which is equal to 9.5. Next we have to find the regression coefficient, that is b of yx and b of xy. The regression coefficient byx is equal to n into sigma xy minus sigma x into sigma y divided by n into sigma x square minus sigma x the whole square. Substituting the values, we get say b of yx is equal to 1.5. Similarly, the regression coefficient b of xy is equal to n into sigma xy minus sigma x into sigma y divided by n into sigma y square minus sigma y the whole square. Substituting the values, we get b of xy is equal to 0.6608. So once if we know the x bar, y bar and the two regression coefficient, then we can able to fix the regression lines. Okay, here the x bar is 6 and y bar is 9.5 and v of yx is 1.5 and v of xy is 0.6608. So using this we are going to find the regression lines. First, regression line y on x is equal to y minus y bar is equal to byx into x minus x bar, which is nothing but y minus 9.5 is equal to 1.5 into x minus 6. On simplification, we got the regression line y on x is equal to y is equal to 1.5x plus 0.5. Similarly, the regression line x and y, the formula is x minus x bar is equal to b of xy into y minus y bar. So, and this if you substitute, we'll get x minus 6 is equal to 0.6608 into y minus 9.5. So, on simplification, we got x is equal to 0.6608 y minus 0.2775. So, these are the two regression lines. And further, using the regression coefficient, we can able to deduce the following things. The first one is the correlation coefficients. So if we know the two regression coefficient v of xy and v of yx, these are the extra informations. Then the correlation coefficient we can able to deduce it. That is r of x comma y is equal to here b of xy and b of yx are positive. Therefore, plus square root of b of xy into b of yx. So you will get 1.5 into 0.6608. So if you take the square root of that, you will get 0.9956. Similarly, we can able to compute the ratio of the variance, that is sigma square x divided by sigma square y will be is equal to b of xy divided by b of yx. So which is equal to 0.6608 divided by 1.5. That is the ratios are the ratio of the variance x and y are 0.6608 is to 1.5. Clear? Thank you.